So we're going to be looking on hydrocarbon. So we want to define hydrocarbon. What is a hydrocarbon? What's hydrocarbon?
A hydrocarbon is a compound that only includes hydrogen and carbon.
Very good. All right. Full discretion. All right. So as Annalise said, a hydrocarbon is compound with carbon and hydrogen only, right? So we need to know three sources of hydrocarbon. So the natural sources of hydrocarbon are coal, natural gas, petroleum, or crude oil. Now, under for a multiple choice question, they're going to ask you which compound, which gas has the highest composition in natural gas. Natural gas is made up mostly of methane. It's not the only gas, but the major component of natural gas is methane. So we need to make a note of it. So here we need to know the definition. Carbon is a compound comprising of carbon and hydrogen only. Source of crude oil is coal, natural gas, petroleum. Another question they can ask you is what's the main component of natural gas? And the main component is methane. Clear?
Yes, miss.
Yes.
All right, no, crude oil and petroleum is separated via a process known as fractional distillation. Now, in fractional distillation, mixtures are separated based on their difference in boiling point, right? So it's their difference in boiling point or difference in volatility. Now, in order to separate crude oil, we are going to use a fractionating column, which is somewhat different from the one that we are used to in the lab, or we use, so this is a specialized process, right? Now, in this process, crude oil here is heated right here, and it's heated to 400 degrees Celsius. When we heat crude oil, the crude oil is the vapors are going to enter. Most of it vaporizes, right? So it's going to enter this device here. I want to use this one. So it enters this device here known as the fractionating column. So it enters this device here known as the fractionating column. Now, what we need to know about the fractionating column is the fractionating column is very cold at the top and it's very warm at the bottom. So the fractionating column has a temperature gradient where it is hottest at the bottom and very cold at the top. Clear? Now, when the vapors enter the fractionating column, so crude oil vaporizes, right? And it goes here. There's a section of crude oil that is not, that when it's heated, that component is not vaporized. What is not vaporized is collected at the bottom, known as the residue. The residue is called bitumen, which is used for road surfacing and roofing. The rest of the crude oil is going to vaporize. As they enter the fractionating column, the vapors are going to rise and they're going to condense. So they're going to rise and then they cool down and then they get heated up again and then they evaporate and then they condense and then they evaporate and then they condense. Now, why is this so? Because distillation is a process which involves evaporation and condensation. And in distillation, we have several rounds of condensation where the vapor is cooled to liquid, and then the liquid is going to heat up and evaporate. So we have several layers of evaporation and condensation. Now, here, we're going to go through the process. So fractional distillation is carried out in the fractionating column. The fractionating column is hot at the bottom and cool at the top, and we spoke about that Crude oil enters the fractionating column and is heated, and so the vapor rises. So the vapor is going to rise up the fractionating column. So they haven't asked this in a long time to explain what happens, but it has been a question in the past. So you may look on some new past paper question and you're like, Miss, I never see this yet, but it has come long, long ago. So you need to know the process. So the vapors of the hydrocarbon with high boiling point will immediately turn to liquid and are topped off at the bottom of the column. Vapors of hydrocarbon with lower boiling point are going to rise to the column, and they're going to be condensed at the top, and they will be topped off. Different fraction condenses at different heights according to their boiling point. So when they get to the section, when the hydrocarbon vapor get to the section of the fractionating column that corresponds with its boiling point, it is going to be topped off. These are the tops that we're seeing here. That is where they're collected. So when they get to the section corresponding to their boiling point, they are going to be topped off at their various boiling points, right? And they're collected as liquid. Now, every fraction is collected as liquid except the smaller hydrocarbons, which are collected at the top, and those are called your refinery gases. Those are collected at the top and they're collected as gas, right? And the fraction with the bigger hydrocarbons are collected in the lower sections of the fractionating column. So let's go again. We heat crude oil to over 400 degrees Celsius. Most of the crude oil is going to vaporize. They are going to, what is not vaporized is collected at the bottom of the can of the fractionating column here, and it's called the residue. The residue actually has an official name, which is butane, and it is used for road and roofing. When the vapors are traveling up the column is hottest at the bottom, coolest at the top. The vapors will enter and they are going to condense at the temperature corresponding to their boiling point. When they condense, they are collected as liquid, except for refiner gases, which is collected at the top as the gas. Do we have any questions? Any questions?
No, miss.
No, miss.
All right. Why this up now, work? So at the top we have, so the lower the carbon number, the lower your boiling point. As the carbon increases, the boiling point increases. So those are collected at the bottom. Now, substances with 1 to 4 carbon are called refinery gases. Yes.
Miss, where is the fraction? Where I see C1 to C4, is that the fraction?
Yes, ma'am, right there. That's where it's gonna go. So C1 to 4 are called refinery gases. They have 1 to 4 carbon. Refinery gases are bottled gas that are used to cooking in our homes. Now, C5 to 9 are naphtha, and naphtha is used to make other petroleum chemicals. They're starting material in the petrochemical industry. Then we have 5 to 10. 5 to 10 are gasoline, and these are used for petrol for vehicles. Then we have 10 to 16, which is kerosene, and kerosene is used as jet fuel. They're also used for lighting and heating and cooking also. Then we have carbons 14 to 20. Those are diesels, and those are used as fuel in trucks and lorries. Then we have carbon 20 to 50. Those are called lubricating oils. And then we have fuel oil, which is 20, which comprises of 20 to 70 carbons, and those are used as fuel in ships, factories, and central heating. And then we have a residue called bitumen, which is used for roofing and road surfacing. Of crude oil. So we have, this doesn't have naphtha, so somewhere along the line, you'll have to remember where naphtha is. So this is an dynamic we can use to remember our fractions of crude oil, which is real guns kill deer by firing bullets, where R is refinery gases, G, gun, stands for gasoline, kerosene, kill, thereby is diesel oil, firing is fuel oil, and bitumen. So give you a minute to write the dynamic off, as well as to record the uses of each fractions of crude oil. This is something that you must remember. Hydrocarbons are a compound that contains the elements hydrogen and carbon. Name two natural sources of hydrocarbon. Two natural sources of hydrocarbon.
Crude
Again,
oil
the
and
questions
natural
are
gas.
extremely repetitive. Natural gas. Why nobody not talk? Crude oil.
What I mean?
All right, ready. Fractional distillation of crude oil produces several fractions containing a range of compounds with varying carbon numbers. Three of these fractions are shown in table 3. Table 3, 3 fractions from crude oil. Fraction 1 contains 1 to 4 carbon. Fraction 2, 12 to 18 carbons. And then 3, 20 to 40 carbons. State the name of fraction 1. What is the name of fraction 1?
Refinery gas.
What's the name of fraction 3? $20 to $40 carbon.
Miss Naphtha.
No, naphtha have 5 to something. 3 in a fraction 3.
Miss Lubricating.
Lubricating oil, and what is it used for?
Miss for wax and polishes.
All right. State one use of fraction 2. One use of fraction 2. Fraction 2 is going to be kerosene. Channel. Fraction. So fraction 2 is kerosene. One use of kerosene.
It's used for cooking.
Okay. All right, very good. Where we're at. I'm gonna introduce us to the question that says draw, and then you need to take it upon yourself to practice how to draw it. Give me a second. Okay, see here. Crude oil is a complex mixture and serve as primary source of a wide range of hydrocarbon. These hydrocarbon can be used directly or further modified to use as feedstock chemicals for a wide range of industrial process. Draw a fully labeled diagram of the industrial apparatus used to separate crude oil into its various hydrocarbon fractions. You should indicate on your diagram the points at which the various fraction comes off. So we're seeing that we should be able to reproduce the drawing. Clear?
Yes,
These are all
please.
CXC questions, so you need to practice that. The first stage in the process of refining crude oil to produce a more value-added product is fractional distillation. Name the property of compound upon which fractional distillation is used. What
The boiling
property?
point.
Which was, say it again?
The boiling point.
Boiling point. Very good. Name the lightest and heaviest fractions that are usually obtained from the fractional distillation of crude oil. Lightest fraction.
Refining gas.
Refining gas. Heaviest fraction.
Bitumen.
Say one use
Miss residue.
bitumen. No, specifically, although it's called, the chemical name for it is bitumen, so we'll use bitumen. Say one use of each of the fraction named in A2 above. Lightest fraction, what do we use it for?
Okay.
All right, so we use it as fuel in cooking. We don't use it, so you need to specify fuel for cooking. I know it's weird, but cooking is vague. We not take them right there. Heaviest fraction, what is bitumen used for?
Road surfacing and roofing.
All right, very good. So we have concluded the first section